Hello students, in this video lecture series, we'll discuss the third part of our chapter number 2, acid, base and salts. So in this lecture, we'll discuss the preparation of some of the important compounds and its application and their uses. So what are those compounds? Let's take a look. Preparation of some of the important compounds. What are those compounds? It's the sodium hydroxide, NaOH. We'll discuss about the preparation of a bleaching powder, calcium oxychloride, baking soda, NaHCO3, washing soda, Na2CO3 10H2O, plaster of Paris, CaSO4 half H2O. So these are the 5 important compounds. We'll be discussing about their preparation and their uses. So let's start. First of all, we'll discuss about the preparation of a sodium hydroxide, which is also called a caustic soda. So here is a formula, sodium hydroxide. Student, now to prepare this sodium hydroxide, what are the materials that we need? So student, raw materials we can say. The materials required are the concentrated solution of NaCl called a brine. That means we'll make a concentrated solution of sodium chloride. So the name of that concentrated solution of a sodium chloride is called a brine. That means that's a raw material that we need for the preparation of a sodium hydroxide. Second part, what is the process followed? To make this sodium hydroxide, the process followed is electrolysis. The name of the process is electrolysis. And during this electrolysis process of a brine, concentrated solution of a sodium chloride called brine, the product formed are sodium hydroxide, chlorine, and hydrogen. Now, chlorine is formed at an electrode called anode, and hydrogen is formed at an electrode called a cathode. And what is the name of the process? This process is also called a chlor-alkali process. We'll see why this process is called a chlor-alkali process. So, student, here is a brief setup for the preparation of sodium hydroxide. So we have a container here. You can see this is a container. So in this container, we have taken a concentrated solution of a sodium chloride called a brine solution. We've immersed the 2 electrodes. These are the electrodes. So one of the electrode is a cathode, another one is an anode. So we have connected this electrode to the battery's plus terminal and this electrode to the battery's minus terminal. So this rod will act like a minus, negative electrode, which is called a cathode. And there's the positive electrode called an anode. So now student, when we plug the key, the electrolysis process begins. So see, you can see in this electrolytes or the solution present inside this container, we have a number of ions: sodium ion, chloride ions, hydrogen ions, hydroxide ions. So the moment we plug the key, the current flow starts and the electrolysis process begins. And the different type of reaction occurs at anode and cathode. So here is one reaction that occurs at anode, which is called oxidation reaction. And this is cathode. At cathode, a reduction process occurs. So because of oxidation process at anode, what is formed? Chlorine is formed. Chlorine is formed at anode. And because of a reduction process occurring at a cathode, hydrogen gas is formed. So that's what we mentioned here. Chlorine is formed at anode and hydrogen gas is formed at cathode. So this chloride ions will move towards the anode and will reduce itself. Not reduce, it's oxidize itself to give us chlorine gas. And this hydrogen ions will move towards the negative electrode to reduce itself to give us hydrogen gas. So hydrogen gas will be collected near the cathode and chlorine gas will be collected near the anode. And what's left with us at the bottom is sodium ions and hydroxide ions. They two combines to give us the sodium hydroxide. So that's how the sodium hydroxide is prepared, student. Now let's move on to the uses of a sodium hydroxide. Student, it's a degreasing of metals. Degreasing of metals. Making soap and detergents. Paper making industries and artificial fibers. Fiber making industries. So these are the places where this sodium hydroxide is used. Now student, the next compound is our baking soda. Sodium hydrogen carbonate. Baking soda. NaHCO3. The chemical name is sodium hydrogen carbonate, or sometimes we call it as a sodium bicarbonate. Let's understand the preparatory reactions of this baking soda. To make this baking soda, we need sodium chloride, common salt, water, carbon dioxide, ammonia. So if we combine this, we get the 2 compounds, this ammonium chloride and sodium hydroxide. So this is our acidic salt. Both are the salts. This is an acidic salt and that's a basic salt. It's a basic salt. It's a mild basic salt is formed. That's what we need. Now say student, pH of NaHCO3 means baking soda is more than 7, so it's a basic salt. Now what are the uses of this baking soda? It's a mild base and is used as an antacid. So when we complain of acidity problem, because it's a mild base, it's a edible, so we can consume it. So when we consume this, the excess acid formed is neutralized by this base and we get rid of that acidity problem. So that's the use. This sodium hydrogen carbonate or baking soda is also used as a soda acid fire extinguisher. And this is also used for making baking powder. Baking powder. Now student, this is one very important decomposition reaction of a baking soda. So when we heat this baking soda, what happens? It decomposes to give us sodium carbonate, water and carbon dioxide. So this reaction is important. It's a very, very important reaction. Now baking powder. Let's see what is baking powder. What is baking soda and what is baking? What is the difference between the two? Baking soda. Baking soda is also used for making baking powder. Now in this baking soda, if we add mild edible acid, now you know what is this H plus? This H plus indicates the acid. If we add the acid, this mixture of a baking soda and acid is called baking powder. So baking powder we are using to bake the cakes or other food items. So say suppose when we are making the cake, we use this baking powder, and when we put that mixture into oven, so these are the reaction taking place. So carbon dioxide is released, water vapor is released, or sodium salt of acid is formed. Now this sodium salt of acid gives the sweet taste to the cake. And this carbon dioxide released in this heating process gives the shape to the cake. It makes the cake soft, spongy and fluffy. So that's the baking powder. That's how we make the baking powder. That's the fine difference between baking soda and baking powder. Now student, let's move on to another compound. That's a sodium carbonate Deca hydrate, which is also called commonly known as a washing soda, Na2CO3 10H2O. So here is a preparation. The crystals of a sodium carbonate, when dissolved in water, it crystallizes to give us sodium carbonate Deca hydrate. That's a washing soda. So by the crystallization process, we make this washing soda. What are the uses of this compound? So it's used in glass industries, soap making industries, paper industries, also used as a cleaning agent. This compound has a special ability of a cleaning. So that's why used as a cleaning agent, and is also used in washing soda. As the name itself says washing soda, it's a part of a detergent powder because of its cleaning ability. Now used in the removal of hardness of water. This compound is also used to remove the hardness of water. Now hardness of water, what does it mean? Hardness of water. Student, hardness of water means when we apply the soap to cloth, sometimes it's very difficult to form a leather. So if leather forming is difficult, it means the water being used by us is a hard water. In short, in hard water, it's difficult to make leather. So to remove that hardness, we use this compound. That's a washing soda. Now student, next one is plaster of Paris, calcium sulfate hemihydrate, CaSO4 half H2O. Now how do we prepare this calcium sulfate hemihydrate or a plaster of Paris? So this compound, calcium sulfate dihydrate, which is also called a gypsum. Now this gypsum, if it is heated at 100 degrees Celsius, this gypsum loses 3/4 of a water molecule. 75% water molecule is lost, and we are left with only half water molecule. And that's what the compound POP, plaster of Paris. Now student, when we are heating this compound gypsum, we must take care about the temperature. The temperature should not exceed 100 degrees Celsius, because if we exceed the temperature above 100 degrees Celsius, then this compound will lose all its water and we will not get the plaster of Paris. So that's why the temperature maintenance is very, very important. So what are the uses of these compounds? So making toys, materials for decoration, and this is also used by the doctors to set the fracture bone in place. So that's the use of the plaster of Paris. Now finally we come to another compound, the last compound, that's a bleaching powder, calcium oxychloride, CaOCl2. So how do we prepare this preparation? Calcium hydroxide, it's a slack lime, dry slack lime. If we pass the chlorine gas through the dry slack lime, we get a compound called a bleaching powder. It's a bleaching powder, calcium oxychloride. So where do we use? We use in cotton, textile industries for bleaching. It's used as oxidizing agent in many chemical industries. It is used for disinfecting water, of killing the germs in water. So these are the important uses, the preparation and the uses of this important compounds. So I hope student you understood the preparation and the uses, the important uses of these compounds. So with that we end today's discussion. Thank you.